Hello, in this lesson, we're going to learn to solve equations with fractions. Okay, you look at these two examples, they both involve fractions, one more complex than the other. But the cool part about math is we can actually get rid of those fractions, all right? We dominate these problems, all right? Or we say denominate, because how are we going to do that? We're going to look at the denominators. So this first example, we have a denominator of 5 and 10. Okay, and the question you have to ask yourself is in order to denominate these fractions, to get rid of them, we got to figure out what are the least common multiples. So I'll write LCM, least common multiple. So we look at 5. What are the multiples of 5? Well, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and so on. Then you look at the other denominator, all right? 10, okay? What are the multiples of 10? 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, and so on. Okay, well, we want to find the least common multiple of the denominators in order to denominate them. When we look at them, they each have a 10. That is the least common, the smallest common problem, or smallest common multiple. So now that we know that, how are we going to use that? Well, we are going to multiply the entire equation by that least common multiple. And that's how we're going to denominate these fractions, all right? We're going to look at the least common denominator of those fractions. So when I do that, here's what happens. Every term is getting multiplied by 10. So I take 1/5 x. That's getting multiplied by 10. I add the 1, which is getting multiplied by 10. And that equals 3/10 x. And again, that's being multiplied by the 10. And then minus 4, which is being multiplied by that 10 as well. So now look what happens to our denominators. The 5 and the 10 cancels out. This just becomes a 2. Okay? Over here, the 10 and the 10 cancel out. It just becomes the 1. And now we just simplify what is left. So we have this 2 times the 1, so that's 2x, plus 10 times 1 is just 10, equals, that's gone, so it's just 3x, because that's a 1, 3 times 1 is still 3, and then minus 4 times 10 is 40. Once you get to this step, now I'm confident this is an equation that everybody can solve, because we have denominated that fraction. We've gotten rid of those denominators. Simply solve. We want to get all the x's on one side, so I'm going to subtract 2x from each side. We've done these steps, but it's worth repeating. So we have 10 equals 3x minus 2x is just 1x, and that's minus 40. Now we want to move that minus 40 to the other side. We add to each, we do the opposite. Remember, inverse operations. So when we do that, we're left with, on the left side, 10 plus 40 is 50. And then on the right, we just have x. So the answer is x equals 50. That's how you denominate fractions. Now let's go back to the top. And let's look at this problem, the problem on the right. Notice it's a little different than our original problem. Okay? There's only fractions. There's no other terms. When you have a problem like this, the key to solving is we actually don't have to, we denominate the fraction, but we do so using a technique called cross multiply. So when it's only fractions, no other terms, okay? Again, no other terms. We can cross multiply. Again, only works when there's no other terms. Here's how we do this. We take the 3, we multiply it by the 5x minus 4, and then we take the 2 and we multiply across. So let's do that over here. So I'm going to take the 3. Now you got to be careful. It's 3 times the parentheses 5x minus 4, and that equals, we'll put our equal sign, the other side, which is the 4 times the 2, and I'll write that out, 4 times 2. From here, we just distribute and solve just like we always have. We don't have to worry about the fractions anymore. 3 times 5x is 15x. 3 times minus 4 is minus 12. On the other side of the equation, we have 4 times 2, which is just 8. Now I get x by itself. So to do that, I'm going to add 12 to each side. So we're going to add 12 here, add 12 here. When I do that, I'm going to be left with 15x equals 8 plus 12 is 20. Want to get x by itself, opposite operation. So I'm going to divide by 15. Divide by 15. So that'll cancel out. I'm going to be left with x equals 20 over 15. We always want to reduce fractions when we can. We got to see if there's any common factors. What divides into both these numbers? 5 actually goes into both. So we're going to divide top and bottom by 5. So we're going to get x equals 20 goes into 5 goes into 24 times. 5 goes into 15 3 times. So that is our final answer. You can make it a mixed number if you'd like to, but you do not need to do that.